We've been studying electricity for 3 chapters now, but not many people know where electricity actually comes from.
The history of electricity dates back to around 600 BC, and it's home to some of the world's greatest philosophers, inventors, scientists, and thinkers.
Let's explore.
Long before any knowledge of electricity existed, people were aware of shocks from electric fish. Ancient Egyptian texts referred to these fish as the thunderer of the Nile. Electric fish were again reported millennia later by ancient Greek, Roman, and Arabic naturalists and physicians. Several ancient writers, such as Pliny the Elder, attested to the numbing effect of electric shocks delivered by catfish and torpedo rays, and they knew that such shocks could travel along conducting objects. Patients suffering from ailments such as gout or headache were directed to touch electric fish in the hope that the powerful jolt might cure them.
Ancient cultures around the Mediterranean knew that certain objects, such as rods of amber, could be rubbed with cat's fur to attract light objects like feathers. Thales of Miletus made a series of observations on static electricity around 600 BC, from which he believed that friction rendered amber magnetic, in contrast to minerals such as magnetite, which needed no rubbing. Thales was incorrect in believing the attraction was due to a magnetic effect, but later science would prove a link between magnetism and electricity. Thales' studies were built upon by further scientists.
For the next 1,000 years, electricity would remain little more than an intellectual curiosity, when the English scientist William Gilbert made a careful study of electricity and magnetism, distinguishing the lodestone effect from static electricity produced by rubbing amber. He invented the term electricus, which is Greek for amber, to refer to the property of attracting small objects after being rubbed. For this distinction, he is known as the father of modern electricity.
As Tom previously mentioned, William Gilbert distinguished the lodestone effect from static electricity. In the image here, fur is rubbed with amber, and we can see the electrons moving from the fur to the amber, eventually creating a static charge. This is how we receive static electricity. In addition, in the 18th century, Benjamin Franklin conducted extensive research in electricity, selling his possessions to fund his work. In June of 1752, he is reputed to have attached a metal key to the bottom of a dampened kite string and flown the kite in a storm-threatened sky. A succession of sparks jumping from the key to the back of his hand showed that the lightning was indeed electrical in nature. He also explained the apparently paradoxical behavior of the Leyden jar as a device for storing large amounts of electrical charge.
A Leyden jar is a device that stores static electricity between two electrodes on the inside and outside of a glass jar. It was used to conduct many early experiments in electricity, and its discovery was of fundamental importance in the study of electricity. Previously, researchers had to resort to insulated conductors of large dimensions to store a charge. However, the Leyden jar provided a much more compact alternative.
Obviously, electricity has been studied for many centuries, but one of the key centuries in the study of electricity is the 19th century, so we decided to give you a brief timeline of the beginning of that century to give you some context about electricity advancements.
In 1800, the first electric battery was invented by Alessandro Volta. The volt is named in his honor.
In 1820, separate experiments by Hans Christian Oersted, A.M. Ampere, and D.F.G. Arago confirmed the relationship between electricity and magnetism. These experiments dated back to William Gilbert and Thames of Miletus.
1 year later, in 1821, Michael Faraday shocked the electric world by producing the first electric motor.
That was cute, Tom. In 1826, George Ohm defined the relationship between power, voltage, current, and resistance in Ohm's law, something that we must dive into. Let's do it. Okay, Tom, that's enough.
Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Introducing the constant of proportionality, the resistance, one arrives at the usual mathematical equation that describes this relationship. I equals V over R, where I is the current through the conductor in units of amperes. V is the potential difference measured across the conductor in units of volts, and R is the resistance of the conductor in units of ohms. More specifically, Ohm's law states that the R in this relation is constant, independent of the current.
Last but surely not least, we'd like to talk about Thomas Edison. In 1878, he founded the Edison Electric Light Company in New York City. He bought a number of patents related to electric lighting and began experiments to develop a practical, long-lasting light bulb. 1 year later, in 1879, after many experiments, Edison invented an incandescent light bulb that could be used for about 40 hours without burning out. Later, by 1880, his bulbs could be used for more than 1,200 hours. In 1882, Thomas Edison opened the Pearl Street Power Station in New York City. The Pearl Street Station was one of the world's first central electric power plants and could power 5,000 lights. The Pearl Street Station was a direct current power system, unlike power systems that we use today, which use alternating current.
The video you will now see sums up some more additional points regarding the history of electricity.
Obviously, electricity has been evolved over many centuries, and we would like to thank you for watching our Theoretical Thursday. We obviously could pack tons of more information in here. However, we gave you the main points, and we hope that you were interested as we were.
Thank you for watching. Stay electric.
The Electric Monster! Electric slide!
Electric! It's electric!
It's electric! It's electric! Thanks for watching again. Tip!